Hello everyone. Today we are going to study a topic which is very important but is slightly confusing. So today I'll be clearing all your concepts related to the topic surds. So to understand surds, we first need to understand rational numbers and irrational numbers. So we all have heard the term rational and irrational. I'm just going to take a quick revision on what is that. So rational numbers are either terminating or recurring. What is the meaning of terminating? Terminating means that the numbers stop or end at a, like they have a fixed end, like 4, 5, 6, 7 and so on. And then there are decimals also, like 2.5, 3.25 or decimals like that. Then there are recurring. Recurring means that the digits in the number are repeating themselves in the numbers are fixed and how they are repeating is fixed. So 2.38, 38, 38 or maybe 5.77777 etc etc. So they do not stop but they continue on. So then there are irrational numbers. They are non-terminating and non-recurring. What does that mean? That they do not have an end, they continue on and they are non-recurring. That means they do not have any fixed order. They are not repeating themselves in a fixed manner. Example is 2.38271594 and it can go on and on. The numbers are not repeating in a fixed pattern or a fixed manner. And then there is the very famous thing pi. Pi also, as we know, is never ending. 22 upon 7 is just the estimated value of pi, but pi is an irrational number because it is never ending, non-terminating, its digit does not repeat, so non-recurring. Now this thing is very important to understand, that rational numbers can either be terminating or they can be recurring. They cannot be both, because terminating are the numbers which stop and recurring are which continue. So that is why they rational numbers I have mentioned or. Second thing is irrational numbers have to be both non-terminating and non-recurring. That is because the digits have to should be never ending. If it becomes terminating, it is rational, and non-recurring also. That means they should not have digits repeating themselves. So here the important word is and, here the important word is or. Okay. So this was about rational numbers and irrational numbers, but I would just like to give you an example. 2.121121112. Is this a rational number or an irrational number? So this continues on. Like again it will be 1 1 1 2, then 1 1 1 1 1, 4 times 1 2. So is this rational or is this irrational? Well, if your answer was that this is irrational, it's absolutely correct. Now why is it irrational even though it is following a fixed pattern 1 2 1 1 2 1 1 1 2? That is because the digits of the number should be repeating themselves in that particular order. So they should not be changing. Like we see 3 8 3 8 3 8. The number of 3's and the number of 8's are not changing. But here the number of 1's are changing. So even if it is in a fixed pattern, it is not considered as a rational number. This was one important thing to know. And now, since we have understood this whole concept of rational and irrational, we can move on to surds. So now, to understand surds, you can see a number here. Now when is this particular number categorized as a surd? So now you know that this is the square root sign, but it is called a surd when the number inside this sign is a positive rational number. So this number has to be positive and rational. this number has to be positive and rational. Then this sign is called the radical sign. And this number, this n here, it has to be a natural number. Now, what are natural numbers? 1 to infinity without including 0. So, now we understand that this should be positive and rational. Positive and rational number, that means recurring or terminating. Then this is called as a radical sign. So, the number inside the radical sign has to be positive and rational. And this number, this nth root of a, this n has to be a natural number. Okay. So, we have understood till here. But now, the main important thing, that this whole number, this whole thing has to be irrational. Yes, only then it is a surd. Now, to give you some examples of this, let's say that we take the square root of 25. Is this a surd? This first step, this is positive, yes. Is this rational? Yes. Then here it is square root, actually square root of 25. So is 2 natural? Yes, 2 is natural, but it's not a surd. Why? Because this whole outcome is rational number, square root of 25 is 5 and this is rational. But we need the outcome as irrational. That is why this is not a surd. Now let me give you some examples of where we will understand the verification of surds better. So here are some examples to understand surds better. Now once we solve them, you will be able to easily identify surds. So the first one is cube root of 81. Now is it a surd or is it not a surd? You might use the LCM method to identify, if it is a perfect cube or not. So 81 is actually not a perfect cube. We know that no cube ends up like no natural numbers cube is 81, and that is why this is a surd. But the first thing that we have to check is that this number has to be positive. Is this positive? Yes. Is this rational? Yes, this is rational. Is this natural? Yes, this is natural. And then we can move on to see if their whole outcome is a rational number or an irrational number. Since cube root of 81 is irrational, that is why we can conclude it as surd. Now let's look at the second example, that is cube root of pi. Now first step, is this positive? Yes, it is positive, but is it a rational number? We have already seen previously that pi is not a rational number, it has a never ending value. So that is why it is not a rational number, and here only we understand that this cannot be a surd. This is not a surd. Now next thing, root of -9. First step only we know that this should be positive. Is this positive? No, this is not positive, and that is why this is also not a surd. It's very easy. You just have to see if the number inside the radical sign is positive, that's the first step. If yes, then you can move ahead. The second step is to check if it is rational. Here in this case it was not rational, but if that is rational, then you can move on to the third step. This number should be a natural number. If yes, then you have to move on to the whole outcome, and if the outcome is irrational, that means definitely it is a surd. Now moving on to this, you might get confused. So this is cube root, so this is root of cube root of 5. Now you might say cube root of 5 is irrational. So obviously this is, even though this is positive, this is not rational, that is why it is not a surd. But there is one step we need to do. Now let's look at only cube root of 5. Cube root of 5 we can also write as 5 raised to 1 by 3. Using the law of indices, that we can write this value as 5 raised to 1 by 3. And since this whole is under root, we can write it as the whole raised to 1 upon 2, because here the value is square root. Now now using the multiplicative identity, so we know that a raised to m whole raised to n is equal to a raised to m into n. That's the law of indices. And so here we will do 5 raised to 1 by 6. Now you know that 5 raised to 1 by 6 can be written as 6th root of 5. So now here we have a positive number, it is rational also. Then this is natural number and the whole outcome is irrational. Therefore it is a surd. You might get confused, but whenever you look at such problems, especially when there is under root there is another root, you might have to do this, and this is a confusing question, so please take this into consideration. Once you start solving the sums, you will be able to understand this concept very clearly. If you have any doubts, I will try to answer them. Please put it in the comment section below and subscribe to my channel Timepass Learning. Thank you.